Hello everyone, and welcome to today's webinar, Securing Kubernetes Applications in Google Cloud with Tigera. I am pleased to introduce today's speaker. It is Amit Gupta. He is the Vice President of Product Management with Tigera. Amit is responsible for the strategy and vision of Tigera's products and leading the delivery of Tigera's roadmap. He has expertise in building software products and services across cloud security, cloud-native applications, public, private cloud infrastructure, and he holds an MBA from the Haas School of Business and his bachelor's in technology and mechanical engineering from IIT Kanpur. So, before I hand it over to Amit, I'd like to go over a few housekeeping items to cover both on this presentation and the webinar platform. So, first off, today's webinar will be recorded, and the on-demand session will be available immediately after the live session ends, and it will be available through the same link that you accessed this presentation. We can also email out copies of this deck. If you would like a copy of the deck, you can just let me know by putting in the questions. You can just say, "Send me the deck," and one of our representatives will get back to you on that. Also, if you look at the attachments and links section, there is a document there, a guide to installing Kubernetes. Installing to network security with Kubernetes, and that's a pretty valuable document. And overall, we'd love to hear from you guys. So if you have questions for our speaker during the session, please feel free to ask through the questions tab. And we will try to get to those questions as they come so that we are relevant to the question instead of waiting till the end. However, we will have a Q&A session at the end where we will cover any questions we didn't get to, or if you have fresh new questions. So, without further ado, I will now hand it over to Amit. Amit, welcome.
Thank you, Michael. Good morning, good afternoon, everybody. Looking forward to the discussion today. Security and Kubernetes. Those are two of my favorite topics. What I have for the agenda today is we will start with a very quick overview of network security, how you should plan and design network security for Kubernetes. Then I'll walk you through our open source project called Tigera Calico. We will then jump into a hands-on tutorial where we will try a full demo on a cluster running in Google Kubernetes Engine. And then we'll close out with some of the advanced network security scenarios with Tigera Secure. So let's jump right into this. Now, before I go into the details of network security, I wanted to kind of just start with giving everybody a quick overview on Tigera. So Tigera has been around for a few years. We are currently the market leader when it comes to zero trust network security and compliance for Kubernetes platform. Our flagship project, Project Calico, today has more than 80,000 clusters across the globe that are being secured by Calico, and this is only a partial phone home data. We make it easy for our users to be able to turn off any kind of phone home information. We are also the co-lead for Istio Security Working Group, very actively engaged there. And it's probably fair to say that Calico and Tigera technologies today are the default standard for network security. I can very confidently say that there is probably nobody out there on the planet who's running production clusters on Kubernetes and is either not already using our technology or have it on their roadmap to do network security. And one of the testament for that is if you look at our customer base today, it touches all segments in the market, whether it's major enterprises running, major enterprises in financial services, manufacturing, some of the largest SaaS providers, telecom companies. We have a whole set of media, gaming, entertainment companies running their production applications on Kubernetes and securing them through Calico. And then last but not the least, obviously, a whole bunch of software and technology firms who have relied on us for network security. Now, it's not just the end users who have been using Tigera products for security. It's also the Tigera products have been embraced by all major cloud providers. So if you look at the managed Kubernetes offering, including Amazon EKS, Microsoft Azure EKS, Google GK, where we'll spend most of the time today, and IBM Kubernetes Service, they all have embraced or have embedded Calico as part of their network security solution. And if a user is deploying commercial distribution, either on-prem or in the cloud, Red Hat, OpenShift, or Docker Enterprise for Kubernetes has Tigera batteries included in the deployment. Now, today we're going to spend most of the time talking about how you can leverage Tigera products on Google Cloud, specifically their GKE offering. Now, I'm very excited to announce or share with you our announcement from last week at Google Cloud Next, where Tigera was included as the embedded technology in Google Cloud and Anthos offering for the GKE on-prem. And we have had a long-standing relationship with Google, but for their GKE offering, and they've now chosen Calico to be a baked-in technology for GKE on-prem as well. And here's a quote from one of the lead product managers for networking, who we work with very, very closely. So what I'm going to do today is walk you through some of the key principles for network security, and then we'll go through a tutorial on GKE Cloud to do some hands-on demo there. Now, before we go into the specifics of network security, it's probably worthwhile to look at what we are seeing with respect to application trends in the market, and you probably are experiencing the same within your respective organization. So it's probably fair to say that today's modern applications are built and deployed vastly different from how things were 5, 6, 10 years ago. Your big, large monolithic applications are now being decomposed into many, many small microservices. Now, that has various different implications. So once you decompose a monolith application into smaller microservices, obviously these microservices, they are stateless, ephemeral, highly dynamic, but the more important part is that the communication between various components of that large monolith application that was typically happening as procedural calls or library calls in an inter-process communication is actually now communication that happens over a network. So from that perspective, if you think about the attack surface for your application, quite frankly, is a lot more expanded. In this specific illustration on the slide, where you see an application with 4 major components is now decomposed into 4 different microservices, and all of these services are communicating over the network. So if you were programming a security model where in the past you were doing network security around the entire application, well, you need to think about designing that security model where each of these individual microservices have a policy enforcement there. And policy enforcement done on each individual microservice, and that gives you a very controlled environment and a better security posture. Now, if you think about, if you're at the early stages of your Kubernetes journey and you are just starting to define the network security model for that, I have few key points to call out as what I call as the key building blocks for network security and compliance. And this is where we'll start with some of the basics, and towards the end of the presentation today, we'll go into some of the more advanced capabilities. But the first thing that you want to think about or design for is how are you going to do identity for your workload or for your microservices in this environment? How are you going to identify the workloads? How are you going to authenticate that? Now, typically in a traditional model, most folks have done that using or relying on IP address-based information. Now, we all know that in a Kubernetes world, that is not the model you can rely on. So think about what are the aspects you will use to identify the workloads in a Kubernetes cluster. So you can use Kubernetes metadata constructs, or even go to a stronger security posture where you're using certificate-based identity. And we'll talk more about that towards the second half of the presentation. The second aspect is that you run your workloads and your clusters and the namespaces in what I call as a default deny model. And fundamentally what that means is that you are essentially going to whitelist all communication, all traffic going in and out of the service. It is super important that you design or you bake that assumption into your security design, because as we all know, most of the security breaches, they come from inside your own network. And if that is indeed the case, you have to work in a model where you do not establish, you're not relying on security based on a particular pod or a workload sitting on an aspect of your network. You have to still whitelist everything. And that's the fundamental building block for a good network security posture. The third aspect that you should design for is you automate this security model as part of your deployment. As we know, deploying Kubernetes workloads is all done in an automated fashion. Part of your CI/CD pipeline will make sure that the security model, the network policies you're going to create, they're all part of your deployment pipeline. And one of the key aspects there is that these policies and the security controls that are deployed in an automated fashion, you don't want to fall back to, or you don't want to rely on your traditional models where there used to be tickets or manual processes around creating these security policies. Bake these control set policies as code as part of your CI/CD pipeline. And then last but not the least is make sure you have granular visibility inside your clusters, into the communication. You are auditing all traffic, all policy enforcement. You're auditing all service token usage, access logs, and so on. It's super critical for you to have that visibility, because as you advance on your Kubernetes journey, you probably are going to be running some mission-critical regulated workloads there, and it's a critical requirement to meet any kind of compliance benchmarks or frameworks that you or your organization may be subject to. So this is a very high level, but a quite foundational building block for how you should think about security. There's obviously details and components that we'll cover there, but definitely plan for these things as early as possible in your design cycles. So once we have these building blocks, now I'm going to talk about how you can implement these building blocks using some of the Tigera products, and we're going to specifically focus on Google Cloud Infrastructure. So Tigera has two main offerings to solve these problems. The first is Tigera Calico, which is our open source tool, and we'll talk more about that. And then the second is our Tigera Secure Enterprise Edition, which essentially allows you to do zero trust network security and compliance across on-prem infrastructure or cloud, and it has advanced security capabilities. So we'll talk about those two products today, but let me first start with Calico. And as I was mentioning earlier, Calico has been around for quite a few years, I believe about 4 years, and Calico right now is can use Calico for virtual machines or bare metal servers, and we have quite a few of our users who actually do the same level of fine-grained access control that they use for network policies across their legacy infrastructure. So with that, what I would like to do today is jump to a live screen. So what we will first do is we will set up a GKE cluster, and for that, what I'm going to do is I'm going to my Google Cloud Console. I'm sure some of you have already used this. So one of the key aspects here is that as you are setting up your GKE cluster, and we'll walk through that here right now. Let me zoom a little bit so that folks can see this well. So this is the standard Google GKE screen. We'll start with a standard cluster. It comes with a name pre-populated. I'm not going to change that. You can choose various different versions, but we'll go with the default here. I'm going to set this to 2-node cluster. I'll go with the default options. Now, this is where it is important that you go ahead and click on this tab where you will be able to choose some advanced options around availability and network security. So we'll leave the availability in the maintenance window as is, but then I want to scroll down to the networking aspect. We'll keep using the default network, and this is where you want to make sure that you have enabled network policy. So the moment you click this checkbox as you're setting up your clusters, this is where you actually have Tigera Calico embedded into this. And what I'll do is I'll click here, so you can get to the Project Calico website as well. You can see all the documentation, but you want to make sure that you enable network policy. Go ahead and make sure take the default options from security, and then we'll scroll down, and I'm going to skip some additional features, but you can see here you can create a Kubernetes dashboard if you want to be able to use a user interface for managing the workloads. You can also enable Istio for service mesh capabilities. We're not going to talk about that in this webinar. And go ahead and click Create on that. Now, typically, it takes about few minutes to get the cluster going. However, for our purposes, for the demo, I actually already have a cluster created. And what I want to do next is I will go through a simple tutorial on how do you do network policies using Calico in GKE. So these links, by the way, are included in the slide. So if you go to Project Calico website, you go to the resources and the documentation, there are quite a few simple tutorials available there. So I'll skip the first one, which I think is really simple, but we'll do a stars policy tutorial. And this is an example of a simple application that has, let me see if I have it running. There you go. Yeah, I have the application running in the cluster. So there's a management UI that you're seeing for the application, and there's a client server, there's a front-end service, and there's a back-end service. Those are illustrated in this picture as C is the client, F is the front-end, and B is the back-end. Now, in this namespace, everything is running in a default allow mode, and that's not a very good security posture. You want to be able to run the namespace in a default deny model. As we talked about earlier, you want to whitelist all traffic, and then you specifically allow traffic that is intended in the namespace. In this case, that will be specifically client is allowed to talk to the front end is allowed to talk to the back end. So we'll just go through a quick demo on that. Now, to do that, what I'm going to do is I'm going to just still use the Google Cloud Platform Connect. This is where you can open a Cloud Shell, and just so that you can see it very well, I'll open the Cloud Shell in a separate window. And what this will do is it will basically give me just a shell command. My kubectl is loaded there. We can just do a kubectl get pods, all namespaces, make sure everything is looking good. And then what we'll do is we'll start implementing some of the policies. So it looks like everything is in good shape. Let's do the first, excuse me, first set of policies, which is we're going to implement isolation there. What essentially it does is, for the stars namespace and the client namespace, I am implementing a default deny. So I copied the command from my browser, and I'm going to just paste it here. And right away, because now we have default deny model, if I go back to my UI and do a refresh here, I'm going to see a blank screen because this management UI has no access to any of the pods or anything. So that's the starting point. Nobody can talk to nobody here. And then we will start implementing policy one by one to enable certain traffic. So the first thing I want to do is I want to allow the UI, this management UI that I was showing you, to access the services, the various services running inside that namespace. So let's copy this command and let's run this inside our Cloud Shell. So that's done. It takes a moment to update it, and as you can see, now my UI has been allowed to access the namespace. The shaded line essentially implies that still any of these components, they're not able to talk to each other, which means the traffic inside the namespace is still restricted as per our design. So now what we're going to do is we're going to enable policies that will allow specific traffic. So let's go back to our tutorial, and the first policy that we will apply, and don't worry, we'll go to the actual details of the policy. I'll walk you through that, but let's apply the policy that will allow traffic going from front end to the back end. So let's run that command here. There you go. So the backend policy is created. Let's go refresh our UI one more time. Takes a few seconds to upload, and now you can see the traffic is indeed flowing from front end to back end. We will now go back to the tutorial, and we're going to apply the policy for the front end service. So let's copy the command. Let's apply here. And at this point, my client should be able to talk to the front end as well. So let's go back and refresh the UI. It takes a few seconds. The policies, by the way, are applied instantly. So within milliseconds, the policies are applied on the application, on the services. While this is uploading, or while this is refreshing, I want to make sure we go through and look at some of these policies. So why don't we take this policy YAML and open this in a window. So let's go here. And let me zoom a little bit. So this is just a quick anatomy of a policy inside Kubernetes. And let's go back to the UI, which is now updated. So you can see here from client, the traffic is flowing to the front end. From front end, the traffic is flowing to the back end. But everything else has not been whitelisted by our policies, and hence that part of the traffic is denied. So that was a very simple, quick tutorial that walks you through the network. There's actually more tutorials here. Sorry, it's zoomed too much here. There are quite a few other tutorials on the Project Calico website. There's a more advanced application layer policy tutorial where you can go through layer 3 to layer 7 policies. We won't go through all of those here, but I wanted to give you an idea about how you create a GKE cluster with Calico enabled, and then run through a hands-on tutorial to get you an idea about how to enforce some of these policies. So now let's switch back to the slides. Give me one moment. There you go. So you saw that we created a GKE cluster with Calico enabled on it. We went through the full tutorial where we whitelisted the traffic. We identified these workloads based on their Kubernetes identity, and we applied segmentation rules there. Now let me walk you through the policies that are there. So specifically, there were two policies that whitelisted the traffic. Let's start with the one on the left, which is the backend policy. And here you define the policy, the namespace, but you can also see in the spec, this is where you're defining a pod selector. Fundamentally, what this means is it allows you to define policies applied to which pods. In this case, specifically, if the role is set to backend, and if we find a pod with the labels where role is set to backend, that's really what this policy would apply to. The next aspect there is what is the traffic rules that we are applying there. So in this case, we are defining ingress rules. By the way, you can define both ingress and egress rules with Calico policies. In this case, we're defining an ingress rule where we are allowing traffic from any pod that has role front end. And we are going to allow that traffic to port 6379 protocol TCP. That's what the configuration is for this particular backend service, accepting traffic from front-end pods. Now let's look at our front-end policy, which again, very simple. The policy applies to all pods that have roles set as front-end, and then there are ingress rules defined where you will accept traffic from any pod, any workload where the role is client, and we are accepting traffic on port 80. And again, I highly recommend that as you define policies in your for your Kubernetes applications, for your infrastructure, make sure you don't leave it open for all ports, even though your service is only listening on one port. It's just a good design practice to define the policy all the way down to protocol and port to only certain workloads that are allowed. So that was a quick tutorial on Tigera Calico and how you can do some fine-grained segmentation on your GKE cloud. Now I'm going to switch the topic to Tigera Secure Enterprise Edition, and typically we see our users as they advance on their journey on Kubernetes, as they start to put more regulated workloads, more mission-critical workloads, they have additional requirements that come from security and compliance team. Typically, it is more fine-grained segmentation all the way down to their web methods and HTTP URLs. The security and the compliance teams have a need to look into what's happening inside the cluster in terms of flow logs, connectivity logs, audit logs. It could be because the security teams want those logs to be consumed inside whatever your log aggregation platform is, your security operations center. And sometimes you need those logs to be able to identify or troubleshoot connectivity into the services. You may want to check if a particular service is down, whether it's a policy denying the traffic or you have a network fabric issue. So when your security and compliance requirements are much more advanced, that's when we recommend our users to deploy Tigera Secure Enterprise Edition. There are 4 major value pillars for the solution. The first one is the ability to deploy a full zero trust network security architecture. The second is get deep visibility, observability, and traceability inside your clusters. The third is around how do you actually enforce continuous compliance across your regulated workloads, build evidence reports, audit data, and troubleshoot environments. And last but not the least, if you have clusters running across a heterogeneous heterogeneous infrastructure on-prem or in the cloud, and you're defining policies that red can talk to green, then red or green could be sitting in any parts of your infrastructure in any different clusters, and you get a federated security model from Tigera Secure. So those are the 4 main value pillars. Excuse me. What I'm going to do next is go into each of these in detail, and then at the end I'll do a quick preview of Tigera Secure product, but not a full demo here. So that there are 5 key principles to a zero trust network security model that we propose to our customers. The first is workload identity. So just like you probably don't want to allow a Heartbeat user to consume a cloud service without multi-factor authentication enabled, you want to follow the same model for your service-to-service communication inside the clusters. And that's very fundamental to our architecture. You have identity or trust established for a service based on multiple sources of identity data. The second aspect is, as you're defining your policy rules, your network policy rules, you define in a unified policy language, in a unified policy model where you have layer 3 to layer 7 rules identified in the same policy. The third aspect is you are deploying your workloads in a least privileged model. Fundamentally, you're defining authorization rules, whitelisting only the traffic that you intend to for that particular microservice. The fourth aspect is defense in depth, and it's super critical, primarily in a highly dynamic environment where we do policy enforcement at multiple enforcement points. And the reason it's very it's a good security posture is if, let's say, your network gets compromised, your application stays secure, or if a certain service that's part of your application gets compromised, you are assured that it's not going to be able to laterally move to your network or your infrastructure. And last but not the least, you have full data in transit encryption enabled using Tigera Secure. So those are the building blocks of a good zero trust network security architecture. I'll double click on some of these. As I was talking about, as you establish trust on your service, we rely on 2 sources of identity data. One coming from your Kubernetes identity, from your Kubernetes API server, and the second is a cryptographic identity based on a X509 certificates. And then as you're defining your authorization rules, you can include your Kubernetes metadata, cloud metadata, your layer 7 request attributes, and gives you the advantage to define a true intent-based security model for your crown jewels. The second aspect here is, as I was talking about, we have a layer 3 to layer 7 enterprise Calico policy model where you can define all the way controls to web methods or HTTP attributes, specific URLs that a particular service is allowed to access. And that gives you a very fine-grained security model. The third aspect, as I was calling out earlier, is we do enforcement at multiple enforcement points at the host, at the pod, and through a sidecar inside your pod. And that gives you multiple trust boundaries and significantly reduces or eliminates the attack surface for your application. The second key aspect of Tigera Secure is the visibility and traceability, and you need visibility for various different reasons. Oftentimes we run into 3 primary use cases. One is network engineers, they're trying to troubleshoot connectivity. There is a service incident and they're trying to figure out, is it the policy that has denied traffic or is it the network fabric? The second is your security teams are looking for granular logs primarily because they want to identify any anomalies, any indicators of compromise on the network and then take corrective remediation actions on that. And last but not the least is your compliance teams who need to maintain a full detailed log of what's of the traffic and the connectivity log inside your clusters. So those are the 3 primary use cases we often run into. There are various sub-scenarios to this, whether it's for your audits and so on. But let me quickly walk you through some of the capabilities from Tigera Secure. So one of the key gaps that most users run into is when they're looking for connectivity logs from traditional tools or traditional architectures is that you get basic 5-tuple information. And it's collected at either the perimeter or the cluster ingress or through some kind of appliance-based model. There are two primary issues with that. One is you are most likely looking at inaccurate information because if you collected the logs through an appliance at a certain place in your architecture, the fact that a network policy is going to deny the traffic, you will see all accepted traffic in your logs, and that's not accurate. So that's the first problem. The second is these logs typically have just 5-tuple information. So source, destination, IP, protocol, port. Now that's great, but as we all know, Kubernetes, the workloads are highly ephemeral. So an IP that was assigned to a front-end service today could be assigned to a back-end service later in the afternoon. So when you are looking at those log files, those IP addresses are quite useless, and there's nothing you can do with that kind of logs. Now, when you compare and contrast that to what Tigera provides, as you can see in this slide, there's 24 different attributes, and we keep adding more and more metadata to your log. Here you're seeing source, destination, pod, namespace, connection bytes, connection count, traffic allowed, denied, traffic direction. So there's a vast amount of data that's available to you to do whatever you need to, whether you're looking for policy mapping, which policies allowed what traffic, and I'll show you a quick demo of this towards the end of the presentation. This is super rich information that security teams just love when it comes to Kubernetes cluster visibility. In addition to the raw logs, we also provide a visualization on the product, and the intent here is that you can actually troubleshoot, navigate through a vast amount of log data to a specific workload and what's going on in terms of network connectivity or network graph for that specific workload. Comes in really handy in troubleshooting scenarios. In addition to that, we also provide a whole set of network metrics, connection metrics, and it's not just for each policies, but also individual rules that you may have defined in the policies. So for example, if let's say you have defined a policy with rules that allow, for example, let's take the scenario of a compliant workload. You define a PCI policy that only PCI workloads are allowed to talk to PCI workloads. Now, if you set those rules and you want to be able to see any violations or alerts on that, or any, so you can set up your denied packet metrics to that specific rule, and as soon as you hit a traffic from a non-PCI workload trying to connect to a PCI workload, you will see these metrics go, or you will see that denied packet metrics count on that rule, and you can set up your thresholds and alerts on that and investigate any kind of rogue traffic that you don't want to allow in your cluster. So again, it comes in very handy when you're trying to monitor your infrastructure from a security and compliance perspective, and helps you automate any kind of security orchestration and incident response workflows. In addition to this base level of visibility, Tigera Secure also provides you anomaly detection. So we look at your baseline patterns for connectivity, traffic, and also your Kubernetes API server logs, and we baseline your systems, and then we will alert you if we see any kind of deviations, protocol deviations, volumetric deviations, if we see any kind of recon activity inside your clusters, any port scans, IP scans happening, any probe coming from bad IPs, known bad IPs, we will track all of that. We will alert you so that you can further build context on that and take corrective actions to quarantine that workload or quarantine that traffic. The third piece is around compliance, and oftentimes when we work with our customers, there are various different teams that are involved in defining and implementing and evaluating various control set for applications. Tigera Secure allows you to define a hierarchical policy model where individual teams, in this illustration you're seeing security team defining higher level policies for their specific security controls. These could be policies for traffic to embargo countries, compliance rules. Then in the middle of the slide, you're seeing the platform team, the team that's actually managing, operating the Kubernetes cluster, and they're defining rules for logging infrastructure, DNS infrastructure. And then last but not the least, on the right, you see the development teams, the actual application or service owners, and they're defining rules for the granular traffic for their specific applications. And you can set all of that up in Tigera Secure in a tiered evaluation order. The last piece here is the multi-cloud aspect of it. So even though we spent most of the time today talking about how Tigera Secure can do security across Kubernetes environment, we actually can extend this model to your virtual machines and bare metal servers. But more importantly, we provide federated security. So if you define a policy that red pods are allowed to talk to the green pods, we will be able to enforce that security across any infrastructure. So you have clusters running in a OpenShift environment, in a Docker environment, Docker Enterprise environment, or you're running open source Kubernetes in any kind of cloud infrastructure, or if you're using any kind of managed Kubernetes offerings, we'll be able to enforce security across all of that. So now what I'll like to do is just give you a quick sneak peek into Tigera Secure product, and then we'll wrap up with some questions at the end. So let me go back to my screen share. Here is just a quick view into the portal that comes with Tigera Secure. What we're looking at right now is a dashboard which tells you a little bit about your deployments, how many endpoints, how many policies. It also gives you real-time metrics into what's happening inside the cluster. So these green bars that you're seeing, they are essentially policies that are protecting workloads. And green means everything is in good shape. We're only seeing traffic that is intended for these workloads. However, if there is any malicious activity or misconfiguration, these bars will indicate red color to show any denied traffic, and you can track and manage that. Here is a quick example of, here's our policy board. As I was talking about hierarchical tiers, so let me just do one thing. Let me hide one of the tiers, but here you can see 3 tiers that I was talking about. The security tier defining a quarantine policy, a PCI whitelist. On the platform tier, I'm defining my logging policies, and on the default tier, I have all my application policies. On this policy board, you can see some additional information, including the traffic stats. So you can see how many endpoints this policy is being applied to, connection counts, allowed, denied, passed traffic as well. And if there's no traffic, you'll see not applicable here, but you can see all the traffic stats for each policy. Now, let me do one thing. Let me just click on one of the policies here, and we provide you a nice UI editor. So if your developers are comfortable with network policies and YAMLs, they can create those themselves, or they can use a policy editor like this, where you set the scope for the policy, you set the labels for which endpoints this policy applies to. You can define ingress and egress rules. and set the rules accordingly. Once you define the policy in this UI, you can just download from here. That will give you the YAML that you could just integrate as part of your CI/CD pipeline, and as the application gets deployed, these policies would be deployed. Here is the visualization I was talking about. I will not go into the details of it, but there are 3 ways to navigate this. The outer ring tells you which namespace. The middle ring is when you want to navigate by the actual pod name, or if you're just looking for allowed and denied traffic, you can go by the inner circle there. Just one last thing before we go to questions here. All of the log data is also available into a Kibana dashboard. So like, for example, there's a couple of dashboards that come with the product. You can look at the flow logs here. And as I was talking about, there's detailed metrics available. So for example, if let's say you want to look at a specific flow log data from Tigera Secure, all of those attributes that I was talking about are available here, including policy name, tiers, actions. So you can see here all the policies that were applied to this traffic and the policy action that was applied here. So there's a lot of rich information available here that customers can use for various different scenarios. So now let me go back to the slides. So that was a quick preview of Tigera Secure. At this point, I will hand it over to you, Michael, for any questions.
Thanks, Amit. That was great. You know, I'm sure there's a lot more that you know about this that you can cover in an hour. So if any of you are interested in going further and maybe receiving more customized demo, definitely let us know. You can pop a question or there's some feedback area also, or you can also always go to our website and fill out a contact request or a demo request. So while we're waiting for questions to come in, we currently, I'm really impressed with you guys. I never have had an audience that is full of Kubernetes and Google Cloud experts and have no questions, because clearly you guys know everything. So I'll give it another minute or two for some questions to come in. And if that's not the case, like I've mentioned before, we typically don't do seed questions, you know, kind of fake questions to like other companies do. We'd like to keep it real with you guys. So nothing's coming in. So listen, if you guys have any questions, feel free to go ahead and get a hold of us. Like I said, through our website, the Contact Us form is a great way to do that. And you can also reply to the emails that invited you to this email, and that is reply@Tigera, and those will get routed to the correct person. So I'd like to thank you guys all for attending. Amit, thank you for presenting, and have a great rest of your day. And we will have another webinar in 2 weeks. It is yet to be determined, the title. And once we have that, you guys will know, and so check back to our channel or stay tuned for announcements from us. Thank you for attending.